platform which allows you to deploy applications at scale. So you can deploy compute, databases, any kinds of networking that's around, so that you don't have to worry about the undifferentiated heavy lifting when you're actually building applications. And that kind of ties into a lot of stuff that I've done over the years, and I think kind of like the role which I'm in right now reflects that. So across the board, I've worked across different kinds of companies. I have been with corporations earlier, and also with small and medium enterprises, and also startups. So I've consulted across startups in Malaysia and in India. And throughout the years, I've kind of done every role under the sun. So I started as a developer, backend developer for Java Enterprise 2005-ish. And then I moved on and did other things like infrastructure management and automation, because over the years, the tooling around this became much, much better. So for people who have heard of cloud and containers, for example, or maybe even CI/CD, things like that start coming in. DevOps is another thing that I was part of, as part of trying to automate infrastructure better and try to work together as a developer and as a person who's managing operations. And I kind of transitioned over into architecture after that. So solution architecture for an enterprise. And the idea is to have a 20,000 and 50,000 feet view of the kind of solutions that are being built and interconnected across an enterprise, so that you get more value for the business and for the stakeholders also. And beyond that, I've also been involved with building teams, and I've been involved in building engineering teams. Me and Amir kind of like, that's where we kind of met as part of Randstad, and I've seen a lot of team dynamics. I've seen this whole thing of testers and developers, how they work together. And I had done a talk in Ministry of Testing last year when we were still able to do physical meetups, where I had kind of spoken a bit about from the developer perspective of testing. I'm not sure if that recording ever came up somewhere, but yeah, there's something we had spoken on that time. And I've always had this a peculiar perspective, I would say, because usually you hear developers are anti-testing, right? They always look at testing as someone who's always putting a break in their work or in their speed of delivery. While I see them always as a force multiplier. I see QA as a force multiplier for developers, because and also as a forcing function. The fact that they actually force you to make code better and make it better, and I kind of see it like that always versus it. Of course, I've always had my run-ins with testing teams across my career, but hey, who doesn't? There's always that thing of, okay, this button should work in a certain way or not. There's only these many ways it can work in. But yeah, that's kind of like how it is. And why I shared a bit of this is it's kind of like it ties into this whole journey of how we've reached where we are in 2021. Some of you, and maybe I'll be asking a couple of questions, and then just once in a while, just looking at the chat to see if any of you have gone through some of the experiences that I'm going through over here, in terms of microservices, in terms of other things. And I'm seeing some attendees are still trickling in. So yeah, that's something I think I may ask a bit later in questions. So I'll quickly dive into the material itself, right? And since everyone's over here about microservices and testing, first question I have for the crowd over here is, how many of you are currently testing against microservices? Or even know about microservices in the first place? Just put a +1 in the chat box if you are. Crick. Okay, it's almost silent. Nobody's there. So okay, all right, fine. Not yet testing. Fair enough. So that's Amir over there. I'm guessing then the crowd over here is kind of interested in what monoliths and microservices is. Primarily, the content today is going to talk about best practices on what to test and how to test. So it kind of it's kind of like it dwells between developers and testers at the same time, because it covers unit testing and other things. Although if folks over here are interested to learn more about monoliths and microservices, there is a lot of content out there. But if you still think you want to have a certain topic on just maybe like a 15-20 minute intro on what monoliths and microservices are and how it works, definitely do put it in the chat box. Maybe that's a topic we can talk of in the next session as a brief interlude of sorts. But I'm going to directly jump into what monoliths and microservices are over here in this case. And basically on the left, what you see is monolith application, right? And this is how applications have been throughout the years. Primarily when I started my career also, it's this one massive code base that where you put in all your functionality, and the key thing is that it works in a single process. So for example, if anyone over here has worked in Java or .NET kind of applications before, and if you're a tester and you had to run this application, you would ideally just get the jar file or the DLL files and then run it as one single process in a CPU. And anytime an error happens within the code, it would stop the whole process, right? And kind of like a stack trace comes up and it's not caught anywhere in the code, and then suddenly your system will exit. I'm sure some of you may have already seen that. A monolith kind of is an architecture from that manner, where all the functionality is sitting within the same code base. It runs within a single process, and and the way you scale it out is like you can see over here, is that the way you scale it out is that you make multiple copies of this. So if, let's say, for example, I want to have 4 times the number of requests handled in a monolith, I would actually have 4 machines or 4 processes running with the whole code base running inside that. Now, I'm kind of alluding to the fact that, okay, with a monolith and a single code base, it's going to be heavy. And yes, it is. And usually with monoliths, if you want to scale them up, you usually do vertical scaling, right? You'll add more RAM, you'll add more CPU to the box if needed. And if you're going to clone machines and you're going to have more physical servers kind of running monoliths, then you need to put something like a load balancer in front, right? So that you can ensure that, okay, the load is distributed equally. But then it also brings in another paradigm of data. How is the database has handled and how is the data handled? And a lot of that is something I would really want to cover if folks are interested in maybe another session of how monoliths and architecture really works, and what as a tester does it matter for you also. Now, the alternate to this whole monolith architecture, and monoliths are good in a certain way. They're good for, like when you're just trying to get started with a certain project, get started with a certain product feature kind of set in mind, and you're not sure how you're supposed to break it out, because in a microservices architecture, that's where it changes. So in a microservices architecture, on the right side over here is where you put each element of functionality into a separate service. And this basically is like you're scaling and you're distributing these services. So think of this as a way where each function, each code, like for example, if you take an e-commerce application, maybe your user registration service is a separate service that runs in a separate process, and then your cart ordering and order processing is another one, payment is another one. And the idea with microservices is that you can scale them independently, right? Based on the load, based on how many people are using that service, you can scale up that specific service, and you can also deploy new changes to that service without affecting something else. Now, that is how a microservice is supposed to function. But as we'll see as part of the slides, what I'm going to be covering is that the complexity that gets added because of microservices is still is kind of there. And as a tester, then you also your much you're testing also starts increasing. And that's a question also I'm curious to hear in terms of what is currently the practice in terms of testing teams in the market, on how you're actually testing different services, for example. If you're not doing microservices, maybe you are doing service-oriented architecture, for example, where you have to run multiple services to test a certain functionality, and how you would do that. Best practices will cover some of that, but it would be great to even hear from all of you on how exactly you're managing that part. Right. So what makes microservices different than an API? I'll touch a bit on this in one of my slides over here. It's actually just the second slide after this. But I'll just touch a bit on what an API is and why the difference. Now, one thing to notice over here is that I haven't talked about the database, right? And databases bring in their own set of architectures. Usually from a monolith and a microservice perspective, this is how it's going to look like. Now, when you have a monolith application, you're going to have a single database where that application is going to be talking to that one database, right? And so this is basically what it is over here. So you have the single database, and then you'll have this is also a monolith in a sense, because you're going to be scaling the machine, right? If anyone has worked with SQL Server, Oracle database, or maybe even MySQL or Postgre, you'll notice that every time you see the database is getting slower, you will have developers and teams trying to tune the SQL queries, try to optimize the database. But if after doing that, it still is slow, then you would bump up the machine, right? You'll increase the RAM, you'll increase the CPU, so that you can actually handle more database queries and handle the data also at the same time. So in a monolith, it will be talking to one single database, so you're fine over there, everything works. But the moment you go to a microservice architecture, what happens is that as part of a service and a function being split out, the service and the function also has to own a database of its own, right? And that brings in a different set of challenges also as part of that, because you can scale a microservice with its data, you now have multiple database and data stores sitting around all across the place, right? And these databases don't actually have to be SQL. Because over the years, what's happened is, if anyone's heard of NoSQL, NoSQL has also become a big major approach to actually implementing databases, right? So you have no schema, you have unstructured data coming in over there. And when you're testing an application, now you're not only testing against rows and columns in a certain table which has a certain relation between the data, right? In SQL, in a relation database, that's what you get. You're now also testing against unstructured data. You may be testing against data that's being pulled down from maybe a social media account, for example, or maybe social media feed. Or if you're in the IoT space, you may be getting you're getting sensor data, right? Which is streaming data that's coming in with a timestamp and maybe some data which is being read from a sensor. Similarly, if you're reading clickstream data from a website which is having analytics, right? So you're actually, every user behavior is being captured and that's being sent as a clickstream, and that data has to be read. So you kind of now are in this realm, and in kind of like in a world where you're having multiple services that are trying to do different things, right? Each service is doing its own thing, but as a tester, when you're actually trying to test these services out, you now don't have a single interface to work with. You don't have a single monolith app which you're testing against, maybe a single UI. You have to test now multiple apps, because if you think about it, in this case, in a monolith, if something fails, the whole monolith goes down, right? So the monolith cannot work anymore. Your application doesn't work. It's easy for you to go to Jira, raise a bug, and you're done. But when it's in a microservice, you are now saying, okay, one service is working, but another service is not working. Yes, from a functionality perspective, maybe you can fail that test and say, okay, fine, this function doesn't work because XYZ services are not working. But nowadays with microservices, what you also see is that graceful failure is a feature, right? So if, let's say, for example, this feature is an order user registration feature, and this feature is like adding new items to a catalog, right, for an e-commerce store. If for some reason this feature fails, it doesn't mean you're going to fail everything else. You're going to just fail a very specific functionality as part of this. So again, it goes back to how much does a QA team actually own in terms of testing? Do they still do functionality testing? Do they do something beyond that or not? And I think the answer right now in 2021 is that it's everything. Let's put it that way, at least from what I'm seeing, because you have developers who are going to test their functionality, like specific ones, like each team would own one specific feature, but a QA team could still be common to all those, the developer team. So again, there's no straight answer for this. The idea is just to give you, okay, if you're doing microservices testing, what's the best practice, and then go from there. And for the API part, let me just see in the chat if something's happened. Oh, okay, he will be back. Okay, all right. So from the API part, it's even the API realm. So I just spoke about databases, but even the APIs has actually changed over the years, right? In my time, when I started working with monoliths and the standard JSP applications, which you could take in .NET as ASP applications, you just had the UI. The testing team would go to the UI, test the UI, and then break the UI, go to the database, see if the data is being updated or not, and everything's fine. They didn't have to worry about networks. They didn't have to worry about APIs. But over the years, that's also changed. So if you go with the kind of multiple clients we have with an application, right? For instance, in this case, in the old days, we just had a web application. Now you have a web application, you have a mobile application, you may have a smart device, maybe an Alexa that's communicating with the service. You may have sensors that are pushing data through an API, and then you have other services. So an API in this case is basically now an application programmable interface, an interface which you put on top of your application so that someone can send data to it, right? And usually that's an API that can be consumed by multiple clients. Now, in this case, what's happening is that even how you create an API has multiple options. So if for folks who have seen a REST API before, like a REST API that gives you a JSON blob object, right? If folks know about JSON, you can go to any website, standard website, and see, okay, you can look at the pets. If you're still new to the whole JSON REST API thing, I would say just search for pet store API and you'll get a sample which is already there on Google somewhere that shows you what an API, REST API is all about. I'm not going to cover what's the basics and all of this, but just to keep in mind that REST APIs was the norm since 2008, and then GraphQL came out as another norm for APIs from Facebook. Thank you, Facebook, for that. The fact that they created queries and objects that are being queried as a graph, right? All the data is related and then it's put in a graph. And sufficient to say that GraphQL is what this logo is over here, functions a bit differently from an API gateway. From a REST API. Now, and the key thing over here is that as a tester, again, this changes the game for you, because now if you are only still testing from a UI perspective, like if you're just a tester for the web app, you're fine. You don't have to know about what the API is being run, whether it's, whether the web app is running with the server or if it's a decoupled server, it doesn't matter. But the moment you start becoming a tester for other services, for example, like maybe a smart device and all that, you will see that you kind of like start going down this path where you have to start testing the APIs directly yourself, because you have multiple moving parts now, right? You have all these different parts that are connecting together, and you want to make sure as a tester whether the UI or the client is broken or the actual API is broken. So that kind of now adds more to your plate as part of the whole testing thing. But all is not lost. The whole idea is that as IT evolves, as the solutions evolve, so will the tooling, so will the best practices also. So don't worry about that. This is basically progress in our case. Of course, it does mean that we have more moving parts, but that also means the end result is that you're getting much better apps in your hand, which you can use, whether it's a mobile device or a computer. If any of you are interested, if you want to ask more questions, please do ask that over here right now. Maybe I may not have any slides to cover that. I may answer it briefly in my case, and maybe that's a note also we can take for future sessions that we can have, because I believe right now even enabling testers, even with the latest concepts, work. Because frankly speaking, I'm just seeing the attendee list. I don't. Most of you are folks I have not seen in the kind of meetups that happen for developers. So that's basically where you should be going if you want to learn more about these things. But I think we can produce some of that content over here. So with microservices in general, having multiple services around over here, the whole testing approach has to be tweaked, right? Because if you take the traditional testing pyramid, right, the very famous one where you have unit tests below, and then you have integration tests, and then integrated tests on top of that. For a long time, this was a very efficient way to organize tests, right? But in microservices, in this whole world of microservices, this is not the case anymore. And some companies and teams argue that this is actively harmful if you go this way. However, it depends. I would say it's a very big it depends over there in that case. But at least it's good to know that maybe there is a certain approach you need to take from microservices testing also. Because the biggest complexity in a microservice is not within the service itself, right? Because think about it. If you have a service that is like just for payment, for example, it's isolated, right? You're assuming that's an isolated service. But for payment to work, there are other services around it that need to be tested also, right? To make sure that you can pass that test saying payment is working fine, right? So it is basically about how that one service which you're testing interacts with other services. And that deserves special attention. So the way you write your test cases, the way your scope for the test cases will change when you actually start looking at microservices as a test. Again, like I'm saying, if you're just doing functional UI testing, then it doesn't matter to you anymore, because you don't need to know what's running behind the scenes, right? It could be even humans who are actually entering the data for you whenever you click on a button. I mean, how does that care for you? You want to make sure that the functionality is working. But with microservices and everything coming on board, as a team, and especially if you're a cross-functional team, and if you're not a team that is a separate QA team, then there is a chance that you may actually get exposed to a lot of the architecture behind this, and may actually push you towards exploring how you can test and make the product better, even from a services perspective. So one thing to understand is that with the microservices architecture, unit tests is something the QA teams usually don't look into, because unit tests are basically from a developer perspective, right? I want to just make sure that functionality changes or not. But from a microservice perspective, what happens is that unit tests are usually small by definition, and it also restricts how you can change the code. But having to change the tests frequently as a developer, you start losing some confidence, because the code is still doing what it is doing. But the problem is the code is not interacting with another service outside. Unit test usually runs in isolation. It doesn't actually run across that. So where you'll start focusing more is the integration and the integrated tests, right? So one approach for this whole microservices testing strategy, Spotify kind of has mentioned about this, and I've put the link over there if you're interested to have a look, is that they talk about testing a testing honeycomb, where they say that the focus has to be on integration tests, right? And you have fewer implementation tests and even fewer integrated tests, or ideally none. So that the article which I've linked over there it's pretty comprehensive. It talks a lot about this. Definitely something you can have a look if you're looking at even maybe service-oriented architecture testing, for that matter. That's I will leave it at that. But that's an approach. But what I'm going to do is now I have a lot of content to cover. I may skip some of this. Maybe even the unit testing part, because it's irrelevant for QA teams usually. But at least it gives you an idea that, okay, even with the traditional tests which you run, because as a tester, you will be familiar with the different types of tests you have to write. At least it'll give you a mental model of what you need to be looking out for when you're actually preparing these tests and then actually doing the tests. So I'll start with unit testing, very high level. At a very high level, a unit test is basically a class method level testing. You're testing each class and method independently by mocking its dependencies. This is something a QA team usually doesn't get into. Usually what you will do is you will actually maybe check the report, right? If a developer of your team is actually doing unit tests and you want to make sure, okay, are they covering the test, covering the code, right? You have like 80% test coverage, as they call it. There are different kinds of metrics for that, but usually test coverage is what you do. It gives the developer good confidence that whatever changes they're making is actually going to work from a functional perspective within that function, right? And the code. So just quick question over here. How many of you have development teams who are actually doing unit testing? Just put a +1 if you are. Put a -1 if you don't. If your teams don't even know what is unit testing. That basically means that we need to talk a lot more about that. -1, okay. All right. I'm sorry. Okay, Najeeba, you're from Moneyline. Ideally, Moneyline, I know some of the folks over there, they are doing unit testing, if I remember correctly. Because you have a massive engineering team over there, right? They do a lot of stuff. All right. Okay, that's good to know. I'm definitely gonna. Right, the dev is doing it. Agreed. Yeah. So what I said is do -1 if your team, the development team. Maybe I should have clarified that, is not doing it. So a QA team usually does not do unit testing because you will have to go to the code and do it. So yeah, Moneyline kind of does that. So you kind of have this mental model already. So it's good for you. I see a plus. I'm assuming that's a +1. All right. So we have 2 teams whose development teams are actually doing it. But we doubt it. Nice. Okay. Right. Fave does it. All right. That's good to know. It's good to see that there's test practices happening, but and that's the point, right? So you want even the developers to own some part of the testing. It shouldn't be like they're using you for testing even the most basic functionality. So that's good to know. And for folks who are doubting it or are not sure, that's something that's a conversation you would want to have with the development team also, right? So I'll quickly just skip through these things. Unit test basically needs to have these attributes. It needs to be efficient and effective. It has to be automated, isolated. It has to be consistent, idempotent. The idea is that code, when you run it, if you look at the code for any unit test, you will notice that it will spin up a test setup or a mock setup, and then it will test the code, and then it will then tear it down after it is tested. And it has to be fast. You cannot have unit tests running for hours and hours. It's something that should be done in minutes for a certain functionality, right? And the ideal properties of a unit test is something like this. So you use the same framework and tool. So if you're using, there are some icons I'll be showing later. So if you're using Java, it's JUnit. If you're using .NET, it's NUnit. And Node.js has its own, Python has its own. And you always have this convention of mocking and stubbing. So it'll never actually interact with an actual service. It was basically about trying to ensure the code is working fine. You're locking the external dependency versions and stuff like that, especially with Node.js, where if anyone has tried Node.js before, it downloads half the internet for running even a simple Hello World app. So you kind of get the idea. And I've always got burnt by some dependency issue in Node.js also. So yeah, that's what unit tests are. When you mock this is how it looks like. So you have a class which is being tested. So you have a test that is going to test the class, the code, the actual code, and then that class, when it interacts with an external service, it will instead interact with a mock layer, right? So that and that usually is kind of something which is injected in during the unit test runtime as part of the setup. This is an example. I won't walk through too much into this, but this is a very basic class where you have a job service, and one of the functions that is being tested over here is that you're given a default method, and then when you call a real method, then no exception is raised. So you're just testing that part. And the job service over here in this case is a mocked service. And this is where maybe a developer would actually test maybe a failed functionality, right? They may simulate a failure and then afterwards put that back. And you'll see me talking about failure simulation a bit more as we progress towards the end of the slides for today. These are some unit testing frameworks that are available. So you have JUnit for Java, Mockito is another one. For .NET, you have NUnit, XUnit, and all these other things. Right. Another one from a developer perspective, what you may have noticed or heard of, maybe some teams here are already following it, is test-driven development. And this is where you write a test for a desired behavior and it should fail initially, right? So what a developer does is they don't write code first, they don't write the functionality code, they actually write a test and then it fails because there's no code to actually pass it, right? And then they write code to make it pass. And when you implement that code, it becomes green. And once it's ready, then you refactor it using the test as a harness. So you're keeping the test as a guide of sorts and then ensuring you're refactoring the code so that it works better. But at least the initial functionality is actually tested well. And this still works with the microservice perspective because you're kind of like you're having developers think about the behavior of the tested object, right? So you're coming out of that whole code logic functionality thing and then thinking from a behavior perspective, thinking this behavior is what would translate to actual business value, right? You're slowly going up the layers in this case. But it's hard to do if you're inexperienced. It's difficult to do if you aren't familiar with the problem domain. But TDD has been shown to, at least, I mean, in anecdotal evidences, has been shown to improve knowledge sharing among people and also code quality. It's easy to onboard teams also when they want to like work on a project that's already been handled with TDD. So that's what TDD. Now we'll slowly start going up the stack. This is where you will see even for a QA team, they would start implementing these things. So you have integration tests. So an integration test basically verifies communication paths and interactions between components to detect interface classes. And in a monolith, you would do integration testing. A developer would kind of do that. Even a QA team would also kind of do that, where they would know, okay, this is like a certain list of a certain set of functions that are being called at a high level between processes. So if it fails, then we want to make sure that we are able to capture it properly, or it shouldn't break the system and all that stuff. So service calls must be made with integration to external services, and integration testing kind of validates that service and a dependency that are working together seamlessly. So this is where you are slowly going up the stack, trying to test with all these surrounding services if needed. With a microservice, definitely then you are having multiple services around that are being integrated, and this is where the first step is you're actually going to be testing it over an HTTP call, right? So an example of this is something like this, where you have a service implementation integration test, and you would still do a mock of some sort. Maybe in this case, perhaps maybe that service can still be mocked to a certain level, or it could be like maybe you're spinning up 2-3 services at the same time to test it. Now, depending on how your infrastructure has been, depending on how you are actually maybe your ops team handles the infrastructure for you. Maybe as a tester, you get some scripts where you can run and set up a test setup immediately and then tear it down when needed, right? I know some teams who do that. They may be using Kubernetes under the hood for spinning up those containers quickly for testing on your purpose, right? Even databases. For some, they may have a test environment already ready, and they're saying, okay, these services are already deployed and running. You just go and test it in, right? So that's kind of like how you would want to start looking at it. So a couple of ways you do this. Component testing is one. So you have microservices, which are a microservice isolated test. So each test is isolated per microservice, and it's deployable and it passes a health check, right? The service is always running. You'll check whether it's always giving back a heartbeat. If some transactions happen after that, you continue checking, it's still giving a heartbeat. And you also want to make sure that that service is able to talk to its dependent database, for example, right? Maybe it has a database it owns, so it should be able to connect to it. It should be able to read data and write data, change the state of the data if needed. But something that's come up quite recently in microservices, but it has been there since the early 2000s, is contract testing. And contract testing is basically where an external microservice, if it's maintained by another team, and you may have this where you have multiple teams owning multiple microservices, right? So a contract test is written that can check whether the contract established is still valid. Now, I don't know if QA teams do this. I know developers do this, at least for now. But I have seen, like with the TDD kind of a thing where you write behavior-driven tests, I have seen test teams also write that. So I wouldn't be surprised if there are QA teams who are also writing contract tests as part of this, because they isolate all the services separately and then write them together. A library that is pretty common nowadays nowadays is called Pact. Basically, it is something that came out from the Ruby world, and now they have Pact for different languages being written. There's a foundation also for this. You can check the URL which I've linked over there. And the key thing in Pact is that you define a pact between a service consumer and a provider, so contract testing, and it enables you to do this kind of testing. And Pact provides you an API that allows service consumers, in this case over here, service consumers to define the HTTP requests, and they will make it to the kind of calls that will be made to a service provider, and the HTTP responses they expect back. So these expectations are used in the consumer specs also. And this is good from a QA team perspective, because now what you're doing is you're kind of helping development teams and product teams to actually define those contracts better, right? Because you could still do functional testing on top of those contracts. You can do some kind of expectation from a business stakeholder perspective. Maybe your product team is also working on APIs, and API becomes a product, right? You're not actually having a client, and that's where QA teams start coming in. And there are some tests which I'll talk about, like load testing and resiliency, that come towards the end, which may actually come as part of that. So you will basically run specs, and the mock service returns the expected response, and their expected responses are then written to a Pact file, and that's how you use it. So best practices in this case is you want to
Just a quick one. Pact is open source too, right?
Yeah, it's open source. Yes.
Okay.
It's open source, but they do have a commercial thingy. So just have a look at their website, and you can see. But all their the libraries are available on GitHub to have a look. So just check that license again once more. There are contributions being done. Yeah. Thanks for that. Right. So ways to recreate test data as part of this is that you want to have API calls to create and delete the data. You will have SQL scripts to drop and recreate the database, right? This is something that's already common when you're doing testing. And then maybe if you're in the container space already, maybe if you're doing Kubernetes, you may create a new database in a container. So you create the database and maybe set the data to a certain timestamp, right? You may actually import a database dump and then do it. But I'm going to show you something else which actually can be done. I'm not showing a demo, but I'm going to just talk about another service that's there that just has been moving around a bit now in the microservices world, where you can actually rerun production data as it is. So kind of cool concept, but we'll have a look at that later. So you have some test data frameworks already available. So you have Flyaway, you have Mockaroo, and then DB Unit, which kind of like is for testing the database also. Best practices when you're testing, like let's say user authentication, is that you would disable user authentication by using flags in the configuration. You would skip authentication and authorization if the flag is set, right? So you're basically like skipping the whole auth service itself so that you can continue to the other part of the functionality. And this is useful because sometimes you're just focusing on the actual functionality of the service versus, trying to test the whole authentication flow, because you're kind of clear that the authentication works. Of course, I mean, you still have to test everything, right? I mean, like we say, the motto for testers is in God we trust, everything else we test. So you would want to do this in certain scenarios. Similarly, when you include user authentication, you would create a regular user for the testing as part of the test setup. So you'll create a new user, you'll get some temporary credentials, and then you will start executing the test as part of that. Trying to wrap all this together, you have different tooling that's already there. You have integration testing frameworks, you have Spring Boot test, you have TestNG, WireMock, Rest Assured, and all that stuff. Now, what I'm going to do is, by the magic of PowerPoint and how it can allow me to skip slides, I'm gonna directly jump into things like you know what, I'll just go to BDD. That's easier over here. Let me see, where's BDD, right? So because I'm just being mindful of time, right? So with I'll quickly mention about behavior-driven development, because you may be already doing this. You're trying to make more prescriptive test cases behind the actual behavior of the functionality, right? So it's kind of, I've seen this, the BDD is an interesting space because you have developers and testers kind of like working on that. Whether together or isolated is like, it depends on your team, but I've seen both work on it. And so it's a development process that focuses on developing software in a way where all stakeholders can play an active and ongoing role. This is where product managers would come in, stakeholders would come in, and then they talk more about the behavior of the application or behavior of the service. So it's a test strategy, and it's also a process. It allows everyone to communicate and have a single ubiquitous language, which allows you everyone to talk about the same process and talk about the same functionality that has to be achieved in this case. With BDD, usually you'll see a user story, right? A user story is used to capture a description, and maybe if you are someone who's using test management tools like Zephyr, integrate with Jira and stuff like that, you may see that this is already there because you can write scripts in a certain way in that, and then try to get a test runner. I think you hook up Zephyr with something else, and then afterwards you get a test runner that can run through those tests, through that behavior, and then ensure that it's working fine. So you have different ways to do that, but ideally, that's, like I said, BDD is something that is a bit more outside of the scope for today. But as part of BDD with behavior, I wanted to talk about a certain concept that's come up recently. So it's basically the concept of shadow data, right? So in shadow data, the whole concept is this: you have systems that behave differently depending on the environment and traffic patterns, and you kind of know this already, right? You may see that you may have a testing environment, and then you have a staging environment in production, and always. Sometimes what happens is the functionality which you're testing, which may work in test and in staging, will fail in production, not because the code is having a problem, but it's because the data that is sitting in production is triggering a certain flow, right, in your code, because of which it actually fails for some reason down the line, right? So what shadow data kind of helps you to do is, it's a technique which allows you to replicate and replay production traffic to any given service, right? So you capture it and then you replay it, and then this would be used against any newly deployed service so that you can test it out. This can happen in real time, or you could take all that replays and then replay it somewhere else, and you have zero impact to production, because all you're doing is that you are kind of like, you may have a service, which I'll show a bit now. You may have a service that is actually sitting and recording all these things that are happening over the network, and then you may spin up another service in production itself, which is a copy of this, to actually replay this. And maybe you have a dummy database that is sitting in production. Maybe that's one option. The other option is you take that replay, the replay data, and then run it in another environment, in a staging environment, for example, to make sure that you are able to replay all of that back. So you have this all comes under functional testing in a way. So you have 𝗟𝗲𝗿, which is a BDD tool, which is there, but you also have GoReplay, which is kind of like essentially what I was alluding to right now. So what GoReplay is it's a QA tool, right, which allows you to record your existing user activity, and it helps you to apply staging and core test environments across, and emulate a production environment within that staging environment. And this effectively gives you a way to run replay data across. And this is an open source project that's already there. Link is in the next slide, and it allows you to read and run that data wherever you need to. So the way it kind of works is that you have a service, and then you have a client, and the client sends some requests to get some response from a service, right? So what GoReplay does is that it sits in your machine together with your service, and then it captures the traffic, it analyzes the traffic on the network interface, and then it reconstructs its records, right, and then stores it in a file. And then you can then take that file and then replicate it in any kind of live environment, whether it's in production or somewhere else. And essentially what you're doing is you're just like replaying the whole thing out, and that's how you will do data. Maybe some of you have heard of a development concept that's being run right now with microservices called event sourcing. Maybe some of you have, maybe some of you are not. I'll assume that you haven't. But event sourcing is kind of another form of replaying. Event sourcing is another form where you have events being stored for a database record, and then you can actually replay the events in a certain sequence to reach that state of data. If that's gone over the head, I'm apologies. I just mentioned that right now, but I just thought maybe if someone even has heard remotely about that, then maybe you'll know what I'm talking about. But in actuality, what you're saying is basically from 9 a.m. to 5 p.m., if I capture all the network traffic that's happening, I can take that replay, take that file, and then replay it somewhere else with a certain test setup, so that I can see what's happening with the data. So you're kind of like emulating what the behavior of your system is, and that's truly behavior testing in a sense, if you notice. So that's kind of like how GoReplay works. Yeah, I mean there are other forms also as part of this. Now I see it's 6:48. So what I'll do is I'm gonna talk a bit about some non-functional testing approaches. Right, I won't go into load testing, because load testing is something which people have already seen, and maybe your team is doing that. Maybe the development team does that still. It could be different, but I'll go into something that's newly out there now, right? So resiliency testing. Now, if you're a team that already has an ops team or is already dabbling in DevOps, you may have heard of this concept of trying to test the resiliency of our services, test the resiliency of the environment to make sure that it is still running when things go bad, right? And the term that has been thrown around quite a lot, thanks to Netflix and others, is chaos engineering. Right. So chaos engineering is a discipline of engineering that targets running experiments on services with a goal of building and validating service resiliency. Because here the goal is that even if a service fails, you still have to make sure everything's running fine. One failure should not become a cascading failure for the whole system to go down. So this is where chaos engineering comes in. So it is basically you're trying to generate more knowledge about how your system works when failures happen, and then you're using this knowledge, you experiment for failures, and then afterwards you are able to, you're able to figure out and handle those failures before they actually happen in production. So companies, if you take Netflix and other big companies, they'll do even something known as game days, where they actually go around trying to break systems, right? Literally as part of chaos engineering, and then they try to break systems and then make sure everything is running fine. And you'll see, maybe initially you may be breaking systems, things don't work, and then you fix it, and then you become better at it. And over the years, that accumulates into a very hardened, a very resilient system, which can withstand a lot of failure also and still continue. So you're intentionally introducing failure into a system with the purpose of validating the design. So to give you an example, here is Gremlin. So Gremlin is doing a CPU attack. So what it does is it is attacking the resources directly. So you have CPU, memory, IO, disk, and an attack on a resource could be for many reasons. It doesn't have to be a hacker per se. It could be also that you're suddenly given a marketing campaign, right? Your maybe marketing team has over ambitiously has given a marketing campaign that has become a super duper hit for your product, and then you're, instead of 1,000 users per day, you're getting 1 million users per day on your service. Well, your CPU is going to get hit, your memory is going to get hit, your IO for the disk is going to get hit. So you're basically you're kind of simulating that resource attack over there. Similarly, state attacks for some other reason. Maybe there's a rogue service behind the scenes, or maybe a service that has gone bad for some reason because of data, and then it's now shutting down itself, right? Or maybe killing processes, dependent processes or workers around it. So you're kind of simulating that as part of this. Then you have network attacks, right? So you have black hole latency, and latency is a very interesting test to have, because with microservices, you'll notice that now you're having more network calls happening across the wire versus it being within one single process, basically within the memory. You will, because of latency and networking, you'll have packet losses, right? You'll hear this more often, where you're transmitting packets, like stream of packets across the network, and then some packets get lost and you can't reconstruct the message. So this is basically how you would do it with Gremlin. And you're basically instrumenting, you can also instrument in the application with like request attacks. There are multiple services available. This is the only place I'm doing a plug for an AWS service. So yeah, please bear with me. So AWS, so you have Gremlin and 𝗟𝗲𝗿 that have been there for some time already. Gremlin is a company of its own. 𝗟𝗲𝗿𝗁 actually came out as an open source project initially. I'm not sure if they're commercialized or not. We announced AWS Fault Injection Simulator last year in reInvent. And basically, Fault Injection Simulator is a fully managed service for running fault injection experiments on AWS. So you would run these experiments, and you would stress test your environments. You create disruptive events like sudden increase in CPU or memory consumption, fault injection experiment also. And so it basically simplifies the whole process of setting up and running controlled fault injection experiments. And you are having controls and guardrails that you're setting up as part of the team's trying to run experiments also. So Fault Injection Simulator kind of helps you to set up all of that and test those guardrails, and also do that within the console itself. So you're able to test all these things out. It is, I believe, available right now. I'm not sure how many regions. That's something we can check on later and see. But this is something I just wanted to put out there. So if anyone's heard of chaos engineering happening, if you're already using AWS as a cloud platform, definitely have a look at this, and you can ask your teams to have a look at it also. Last but not the least, I'll just quickly mention about security testing. And with security tests, it's basically a type of software testing that uncovers vulnerability to the system. Now, if you'll notice over the years, with the kind of applications we've been building, the kind of dependencies we have, like open source dependencies, third-party dependencies, and all that, we require testing of even the software packages that are coming in right now, right? Because from a security perspective, you may have a package that you have downloaded that may actually be a rogue package of some sort. So that is one aspect of it. And then you have other aspects also, which are common vulnerabilities where you're trying to have weakness of a system that can be exploited, or maybe poorly chosen passwords, for example, maybe programs with unnecessary privileges, because the more services you have around, maybe to run one service, you may be adding on more privilege to that service to access another service when it actually just needs to read that service, right, to just get some data versus actually doing some changes. And you will see this coming up more often, especially with the whole microservice paradigm coming in, because you have more services running around. You may have programs with known flaws also coming in, weak firewall because of networking again, and also known problems with now cryptography and unencrypted communication. Now, by default, everything has to be SSL as much as possible. You cannot afford to have anything running on a wire that is not encrypted, right? And that's not secure. So you want to test that part. You want to make sure that all of that is the transmission of data is secure, and all the data that's being handled is securely being done. So there are different security tools available. I won't go into all of them, but these are already available. Some of them are paid. I think Snyk has maybe a free service somewhere, but it's also having a commercial paid service as part of this. One thing I'll just quickly mention is that with CI/CD, if you're already part of a team where you're doing CI/CD as part of a DevOps team or an approach where you have a CI/CD pipeline for building applications, you may have noticed that you need to have multiple test perspectives, because you may have builds being done across different stages also as part of the build, and you want to make sure that you have multiple filters in place so that you can provide more effective ways of testing these things out. So you want to basically fail fast. You want to find defects as soon as possible. Automated testing helps a lot in this case, but you also want to make sure that you're able to have test coverage from a unit test perspective from the developers, all the way to your behavior testing that can be run automatically on top of this as part of the CI/CD pipeline. So as much as possible, you want to do that. And at a high level, this is how a pipeline would look like. That's an architecture where if you plug in all these tests, which we have spoken of at a very high level today, whether it's unit tests, whether it's integration tests, functional tests, and non-functional tests, this is basically how it's going to look like. So you have all of these plugged in a certain way, and you may be doing it in a different way at your team also. I'm curious to hear about how that works in this case. So with that, and that's my last technical side. I have this one. I don't know why my QR code is not showing. Let me see if I can just quickly come out of this and show you my QR code. If not, then apologies on that. Is that or you can reach out to me separately? Yeah, I think there's an error in my image. Right. So this is basically I'm calling community speaker. So I run a program called devex Mentor as part of being a developer SA in ASEAN. So the whole program is actually for community speakers looking help in. If you're a community speaker or someone who's actually aspiring to talk in the community and you're looking for help in content, in samples, or maybe even just guidance in how you want to speak, you can join this program. I'll paste the link in the chat maybe in a minute. And what happens is when you join this program as a mentor, you can continue giving talks wherever you want, however you want, but you get a buddy solutions architect like me, or someone else who would actually work with you whenever you're giving talks. We'll just say, okay, what are you talking about? Do you need some help in the way you're giving your talk? Do you need a review for that? And what you would do is then you would then create much more impactful content out there. And you also get a chance to get, swags is definitely there as part of any program, but you also get a chance to give out credits to certain people if needed as part of the program also. So it's kind of like we are cultivating this whole community of speakers who could be also potential mentors for a community. Like Ministry of Testing is a great place, because this is the only place I see QA folks coming in, except for Amir, because I know Amir comes for DevOps also. But that's like, basically it's like you want to build community folks who can speak more about QA, right? You want to talk more about QA, talk about your perspective, and then pull in the developer crowd here so that they can actually listen to your perspective and thoughts, so that they don't also nag you when you're doing your job well, right? So that's basically how I would put it in my case. So yeah.
Wow, that's a really nice offer actually. So let me clear that.
Yeah, let me see if I can find that link quickly.
All right, cool. So let me scroll. There's one or two questions here from the crowd. Let me just scroll down. This one from 𝗟𝗲𝗿𝗀𝗀. I hope I pronounced your name right. So maybe someone has experience for this situation where we have different teams working on different microservices or parts of a big product. So QA is one of those teams. I'm wondering who owns the end-to-end quality or testing. Yeah.
Okay, good question. And I think this is where I would talk a bit about my experience. I don't say there is right or wrong in this. That traditionally, if you notice from development team perspective, function has always been separated, right, from years before. So you have a development team, you have a QA team, and then you will have maybe another team that is handling the infrastructure and the operations. That model has changed over the years, but we still see teams following this still as a separate function. Over the years, you've seen this transition for creating cross-functional teams. So you'll have a team that will have a developer, you will have a tester also in that team, you'll have also somebody who handles the operations as part of that team, or maybe as a kind of a function that cuts across multiple teams. Now the thing is, when you treat QA as a separate isolated team, then it's very difficult for you to actually be part of this whole microservices culture, because you're kind of being isolated from it. You're being given this whole product, assuming that you only are looking at it from a product perspective and not from a services perspective behind the scenes. So that's one. The team structure matters a lot. If you've heard of Conway's law, that kind of starts coming in as part of this thing. Hey, just a sec. My cable's gone. All right. Just give me a sec. My screen's just gone bad. Right. So you kind of have that as part of the setup. Let me just move this here. Yeah, this is easier. I can at least look at you guys. Because my cable just suddenly died on me. Right. So that's one. The second thing is that you, as part of being a QA member, the question is, are you someone who's just at the receiving end of when a product is being built and given out, or are you also part of the process from the beginning, right? So if you're working in an agile environment, assuming you're following agile in the way it's supposed to be followed, are you part of the whole product discussion in the first place? Are you part of the whole stakeholder management in the first place? Because if you're not, right, then in the end, it's just a black box that's being given to you, and you're going to test on that black box and then just give it out from there. So when you see who owns end-to-end quality, ideally it should be the whole team, right? So this is where if you have a cross-functional team, then that team will own that service and will also own the quality of that service. Now, the moment when you have the person who's testing the quality separate from this whole picture, then this question starts arising. Who's owning the quality, right? Ideally, definitely the person who's building the product has to own the quality. But then you're also part of that responsibility, because you're ensuring that if something is not at par or it's not meeting a bar, you're basically taking it back to the team who has developed it and then saying, you know what, you haven't, it's not working, or it's breaking, because we need to be achieving this. And I think that's where the conversations you have matter, because think about it from this angle, right? As a developer, when I see it, and I'm now putting my developer hat on my head, is that when I speak to a tester, and if a tester talks to me about something not working functionally in a code, then I may argue, right? Because I'm saying, I wrote this code, I've tested it, I know it works, right? But if you come and talk to me from a functional perspective, from a business perspective, say this is what I'm trying to achieve as a business user. So now I'm being a XYZ user who's going to use this app in a certain way. I need this app to work in this way so that I can do another functionality. So that's when you are having a more productive conversation with me as a developer. Ideally, you would want developers also to think from that angle, but hey, you know what? We are all focused on just writing more code on the keyboard. So that's kind of like how you would want to see it. So this is how I would see it. There is a lot of culture bit as part of this whole idea which you're talking about, and also about having more conversations. Definitely, this is an online session, so I would love to actually have a face-to-face and then talk, more over 𝗟𝗲𝗿 or something about this, because this is stuff that interests me a lot. But yeah, that's basically how I would put it.
Yeah. I think one more thing about this is that it can be a group thing, but you can also do rotation of responsibilities between team. Because if you're cross-functional and you also can code, then doesn't mean that you always stay in the automation space. You can also move to the developer, and the developer can move to the code. So that's something I've experienced as well. People, I know they got bored doing coding for products. They just code for automation and they switch jobs like that. So yeah, that's something I've heard as well. But to me, that's a truly cross-functional team. People can code and people can test. So that's quite of a rare breed of team, I guess. Yeah.
Yeah, rare, definitely rare indeed. But I mean, it's definitely still there out there somehow.
Yeah, exactly. Yeah.
Let me just quickly paste this here and share my screen. Let me just do this quickly, and I'll just show the QR code if you're all interested in. That's the thingy. Okay, here it is. Share my screen.
Are you pasting in the chat or what? Is it possible to even paste in the chat?
Can I paste images in the chat?
Oh, I just see icons to maybe links, yes, but icons no, or pictures I don't see it.
That's okay. I'll just do this quickly.
Okay.
I'll just share this.
Right. Got a message for Omka saying I would like to have more online sessions as I'm residing in India.
Oh, okay. Yeah, sure. I mean, you should ask Amir to do more online sessions then.
Yeah, we do. We normally do this once a month. During, I mean, usually I have a set schedule, but this month I'm doing it a bit earlier because of the Ramadan coming up. So yeah.
Yeah, totally. Yeah, and Ramadan also coming up. That's also there. So the thing is, definitely having more sessions like this help, because I believe having more conversations on this. Also, when you have folks from other teams also as part of this conversation really helps. So when you are doing these sessions, if you can invite, maybe what you should do is you should try to rope in some of your developers and say, hey, you know what, we're having this QA testing meetup that's happening. Come and listen to what the QA perspective is also, right? Some people may agree, some people won't, but yeah, at least you'll get that.
All right. Any more questions? Anyone want to speak up? Just raise your hand. Turn on your mic and you can ask questions or not. So actually, this week I was trying to do some research on contract testing. That's why I found about Pact and everything, and I saw it was open source, but I haven't really read out how to deploy that on my servers actually. So I'm gonna go ahead and talk about that.
Yeah, definitely. I mean, that's something that's new in my case also, because I'm kind of like seeing this from this perspective. From contract testing. Contract testing has been there for many years. We used to kind of do that in the old days when we used to have RPC network calls. So we used to do Korba and all the things with telcos and banks and all that. So you needed to have contract tests before. So it's not a new concept. But with microservices, the approach changes a bit, because even your network protocols have changed, and the way the data is being sent across changes, and the services also, what they do, it's not straightforward anymore. So let's put it that way. So yeah, I mean, Pact is an interesting thing to look at, and definitely, I mean, I'm curious to hear maybe somebody here tries it out and then talks about it in the future also.
When you mentioned Korba just now, my mind went back to my days of university. I was doing a thesis on that RPC.
Yeah, I was using it. So I mean, telcos, that's the only approach you had for RPC at that time. So.
Yeah. One more question. Is there any open source platform where we can get microservices for testing practice?
Oh, you want to set up a microservice for testing practice? I mean, what you could do is you could try running Docker containers on your laptop, for example, or maybe get a cheap server somewhere and then run some Docker containers. There are GitHub projects available where you set up certain microservices. They may have some sample microservices. I don't have any links right now in my head, but definitely if you search around, it's there. Once you set it up, you can then start doing some kind of testing. But I understand where you're coming from. You want to actually have a simulation environment of sorts where you can actually go in and then do stuff with it. If someone's interested to build a startup around that,
I think this on this topic as well. I did find some links and also articles within the Ministry of Testing site about testing microservices, and they also have a site where people can call APIs. Again, on top of my head, I can't find it, but do go to the site ministryoftesting.com and try to search in that site. Yeah,
that's good, and that's a good question. I think that's a really good way to to get your hands dirty in this kind of testing, and gives you an overall look. In fact, when you do this testing yourself, simulation, you can actually go back to the developers and talk to them about, are you building this right? This is how you're supposed to do it.
Definitely one of the good bullets to have,
Yeah.
All right. There's no more question. I think we've close past 1 hour. I think 2 or 3 minutes past 1 hour. So with that, I would like to thank you first for your time here. I really much appreciate it. Actually, earlier on when you said you were at the first MoT meetup, actually look back, and actually it's almost 1 year. We had our first meeting in March.
Yep, it's been a year. Yes.
Yeah.
So thanks for having me again.
I think we should call your every anniversary then.
It's like an annual talk, right? Yeah, why not? A ritual of sorts.
All right. Okay, so with that, I would like to thank everyone for their time. And also, this is recorded, so I'll share the link for this YouTube video, and so that you can, if you have time, you can pass it to friends or whatnot. All right.
Yep.
So, yeah, thanks everyone, and have a good weekend. Thank you.
Thank you. See you all.
Bye.
Bye.
Salam.